Okay guys, today we're going to continue our person class. One thing I haven't been doing, other than in our initial constructor, was commenting too much. As I said in the methods unit, commenting is not something you should always just put aside. Obviously this is an example, but here again, a reason why commenting can be important is when you use methods, and even things like the navigator along the side here, it's handy to have the comments on hand. So, oh, person is a constructor method, etc. Now that we're using multiple classes, and I'm in a different class when I, for example, construct a person, and I want to know what the talk method is, it might be important for me to actually comment on that talk method and say, you know what, /**, this outputs information about the person. Okay, so if I write that in as a comment, when I'm back here and I'm thinking about what is this talk method, and I go here, I get that documentation handy. And especially because I'm in different classes now, that documentation just becomes something that I can access. So although we're not going to take the time to comment all our methods, it is a good idea to remember that that is an important part of the programming process, that it's just handy to have comments in there in this style so that they can get picked up. What we finished with last class, right at Friday last week, was this idea that we're taking our properties and methods and changing the name here to either public or private. And this enforces something called encapsulation. Okay? Which basically means hiding or showing what's needed outside the class. So outside the class, do I hide the age? Do I hide these things? But outside the class, I will show them what the name is because it's public. I can do the same thing with methods if I want. I can say, can this action happen outside the class or not outside the class by making it public or private? This is that concept again of encapsulation. That was the last concept we looked at on Friday. And there is slide notes on this, okay? So by hiding the properties, we cannot modify the properties unless we go through our methods, okay, like birthday. Hidden methods can also be used as utility or helper methods inside the class. So why don't we, for fun, write a method that if we needed to change, for example, the gender, we could do that. So let's add another method to our person class. So right under birthday, let's write a method, public void operation. Okay? And here's the way the method's going to go. If this person is a male, then, whoops, they are now not a male. So by performing an operation, if they are a male, now they're not. Otherwise, else, they already are not a male, so now they will become a male. Okay? Now, I could absolutely put the curly brackets on this and do actually recommend that for the most part because it's sometimes hard to track where if statements begin and end, right? You can see there. If they are a male, now they're not a male. Otherwise, they're not a male, so now they are a male. So this is just basically flipping the switch on that Boolean variable. But as you know, now that you have had a little experience with programming, we don't necessarily need those curly brackets when it's one line of code. And actually, if you want, you can actually move it up like this to the same line as the if statement even. So if you're starting to get more comfortable with your if statements, you can also think of writing them like this now. I'm not saying you have to. There's nothing wrong with writing it the other way. But now that you have some experience, that's another way you can look at it. Okay, let's test this method. Let's go back to our example. We had Jacob talk. That was the last thing we did. Let's say Jacob dot operation. Okay. And then let's have Jacob talk again. So right here we said, and you may remember this was the use of our constructor, our overloaded constructor. We said we have a person called Jacob Twilight. 26 is a male. We had Jacob talk. Now we're giving Jacob an operation. And now we're going to have Jacob talk again. And on the final line, I am Jacob Twilight. I am 26 years old. And if you're wondering if I'm a male, the answer is false. So we just gave Jacob a operation. Maybe we should have named Jacob Caitlin or Bruce. You guys know what I'm talking about? No. All right, one more method in the person class. No, because do we need a method?
Well, but if they have an operation, shouldn't they also?
They might, but no, but from a code standpoint, name is public. So we can actually code that in from outside the class. We can say that. The other one we can't change is age. Only through birthday can we do that. But let's give this person the ability to change time. How about this? Public void birthday, again. So I'm overloading this method, and I'm going to give it a parameter, how many birthdays, a number of birthdays. So I'm going to use this variable as a parameter to say, give this person 10 birthdays. And all I'm going to do is run a for loop from 0 to number and just call the other birthday method. So I'm going to say, here, do this many birthdays, which, as you know, increases the age by 1. And this is just another example of us overloading a method and giving access to our code in that way. So now let's go back here. Let's give Jacob.birthday. Let's give him 200 birthdays. And then let's have Jacob talk. Actually, as per said by Dawson, let's change Jacob's name. What would be the female version of Jacob? Nope. Nope. Sorry, Peter. Overruled. Somebody else. Someone more qualified. The 2 girls, perhaps. What would be, or the 3 girls, pardon me, 3 girls. What would be a female version of Jacob? Jackie? Like that? You think? So Jacob Twilight's going to become Jackie Twilight. I like it. Good work. See? That's why I ask Aaron and not you, Peter, not some weird answer like that. All right, so there we go. Now I'm going to play this, and let's see what happens when Jacob talks. I am Jackie Twilight. I am 226 years old. And if you're wondering if I'm a male, the answer is false. So we are able to, through our methods, perform the actions and modify things within our class as much as we can. So this is an introduction to this idea of classes building all the logic into one piece of code, the properties and the methods together. Okay. We are now moving to the next big concept in classes. And this concept is borrowed from biology. So how many of you have heard of this word before? Alex, have you heard of this? What does this word mean before I define it for you? Where have you heard it before?
Well, you inherit things from
Inherit things from your parents, like money. You can inherit money from, say, your grandparents or your great-grandparents when they pass away. But what else can you inherit? Diseases? Yes. Maybe we could go a little less dark. How about things like hair color, eye color, baldness, ability to play music? I mean, there's lots of things you can inherit. You can inherit both properties, like hair color, but you can also inherit actions, right? Like, say your parent was a good athlete, you might be a good athlete. Maybe your parent was a bad athlete, and these are things that we can inherit, and that's what it means as well in computer science. It's a feature of object-oriented programming, this idea of inheritance, which borrows from biology, the concept where children inherit traits from the parents. So in other words, one class can pass on properties and methods to another class. And then, hopefully, improve upon those properties and methods. Because really, kids, shouldn't you be an improvement on your parents? Isn't that ultimately your parents' goal? And how will you be a disappointment to your parents? When you do not improve on that. There you go. I don't know. That's up to your parents to decide. That's a philosophical question, not a computer science question. So I'm going to summarize this relationship quite simply as a is-a relationship, right? So you is a person from your parents. And that's not good grammar, but we're going to see how that applies. Okay, whoops. So here's again how I can diagram it for you. So what we can have is a child-parent relationship. So we have a class, and we're going to have another class. One class will be the parent. One class will be the child. The child will inherit all the properties and methods from the parent. So in other words, this child is a version of the parent. That makes sense, I hope. So here's those words getting tossed around. Inherits, is a, okay? Now we'll pick out some computer science terms that are going to be used. One of them is the word extends. This is a term that essentially just means inherits. If you extend something, you're extending beyond what it was there. We'll also be using the words superclass and subclass. Superclass refers to the parents. Subclass refers to the child. Another name for a parent is a base class. It's the base of other things, okay? Now, this is a different type of relationship. We can have classes talk to one another without being fancy inheritance type relationships. That's known as just an associate class. They're just associating with one another. Like, for example, everyone in the room, you're all just associates. None of you inherit from the other. None of you are parent-child in here, as far as I'm aware. None of you are parent and child in here, right? So those are the two types of relationships. Now, the associate relationship is often just called the has-a relationship. We'll talk more about that in a minute. Let's apply this to our example. What I'd like you guys to do now is we're going to create another class in our project. So I want you to right-click on the package and go to New Java Class again. Right-click, New Java Class. Now we made a person. What we're now going to make with our new class is a student. So with a capital S, make a student class. And then click Finish. Okay. So what you should see now is sitting in your project folder is the original example, the person class we made, and now a student class we made. This student class should look something like this. Let me just get rid of the comments. That's not necessary right now. But your student class would look something like this, if I'm not mistaken. Okay, it's currently empty. It's ready for us to put code in. But here's one of the advantages that object-oriented programming recognized. Student's going to need a name and an age and all that stuff. It's going to need all that. So why should I repeat myself with code I've already written when I can just change the way this code runs by adding to this line up top here called the signature line of the class. And at the end of it say extends. Notice that's a blue keyword. By putting that blue keyword extends, it initiates inheritance. But extends what? Oh, well, a student extends person. Now, remember, I said an easier way to think of this is instead of the word extends, oops, just shorten that down to two simple words. Is a. So in other words, a student is a person. Okay? All right. So if a student is a person, it just inherited all the properties and methods. Let's test that before we write any code in here. So let's go back to our example. And after Jacob, let's make a student. Student equals new student. Okay. Notice we can write that line of code and it goes, oh, I know what you're talking about. You've made a class for me called student, so I know what you're talking about. But we're not done yet. Watch this. I can then go student dot And look what pops up. Name, birthday, die, talk. Where did it get those methods from? It got them from the person class. It inherited them. So I can have a student talk without writing any code for this. If I play it, I am Jane Doe. It's picking it up just as if it was a person. So a student is a person. So it picked up all the code. It inherited all the properties and all the methods. Neat, but why bother? Why didn't I just make it a person? Well, the whole idea of an inheritance is you not only inherit all that stuff, but then you improve on it. So we're going to improve on the person class by adding new features to it. All right. All right, I have a little bit of slide notes on this. I just want to show you. So we have two types of relationships. The is-a relationship, which is the inheritance one we were just talking about, and the has-a relationship, which is not inheritance. It's just where one class is just communicating with another class. It's a simpler relationship. And both of these relationships are used to share data or information. So let's say we had a superclass called A. This is our superclass. Then we had B. B is a child of A. So B is a A. So it's a subclass of A. So there's some of those terms, right? This is the superclass. This is the subclass. B is a A, or B is the child of A. C is the child of A. So one parent can have multiple children. That makes sense. And similarly here, one superclass can have inheritance towards many subclasses. Now, it just so happens that this class C has a relationship with F, but it's not inheritance. These two classes just send information back and forth to one another. So in other words, C has a relationship with F. So they're what are called associate classes. Whereas these, it's inheritance. Okay? So if we use this as a real life example, I could say, you know, Bob has two children, Dave and Sally. Sally has a boyfriend called John. John and Sally are not related, but they have a relationship. They're associates. Now we can keep going. We can say, oh, well, D is a child of B, and E is a child of B, and E has a relationship with G, and G is a child of C. So the way classes can start communicating with each other can get very complicated. And actually, that's one of the reasons why if you take my computer science 40S course, we do a lot more work on classes. It's an important unit, but it's a starting point of much more learning on how this works. Now, we're not going to build something quite this complicated, but we're going to apply this to our example. So let's go over to our student class. Okay? What makes a student different than a person? Well, okay, no, go ahead and talk, but here's the first thing. This is what we have so far. Student is a person. Person is the superclass. Student is the subclass. Student extends person. Okay? What about some of the properties we can add to student? Now remember, we already have all the person properties. So what if we added student number? That's an integer. What if we added their average? We'll make that a double, right? You guys know about like grade point average, right? What about methods? Well, we could make our constructor. We could make a method to study. That's what students do. We could make a method to slack off. That's what a lot of students are doing right now. And what they should be doing, cramming right before a big test. Let's do those four methods. Now, the way I wrote this here, I'm going to also imply this. If I put a plus sign, that means it's public. If I put a minus sign, I'm going to say that means it's private. So just by putting that there, it gives us an idea of what we can write in our code. So let's write it. Let's go to our student class and write in what I just said. So I said that we would be having a private integer for the student number. That will store a student's student number. It's one of the things you guys have to use when you get a timetable or take out a book in the library. You need to know your student number. Let's also make a private double for your grade point average. Do you guys know that term, GPA? You ever heard of it? Grade point average? Do you guys use that here? I don't think so. It is a big deal when you get into post-secondary schools like universities and colleges. They track your grade point average quite highly. It is a factor in a lot of American schools as well that's a big deal. But let's just put that, you know what, maybe I'll rename it since we're not that familiar with it. I'll just call it average.
So, wait, why does the high schools like not use grade point average?
I don't know. That's a good question, Dawson. I have no idea why this high school in this school division in this province in this country doesn't make a big deal about grade point averages. When I was in high school back in the 80s, it was printed right on our report cards what our grade point average was, which was just an average of all the courses you took. I would think so. I'm surprised you don't. I don't. Really? Well, how do I see it? I don't know how to see it, but no, I don't want to know right now. Okay, hang on. We got to keep moving. Now, we also said we're going to write 4 methods. 5 methods, pardon me. One was a constructor. So what do you remember about constructors? They're public. What else? Dawson, remember? No return type, not even the word void. And then the name of the constructor is the same as the class. So there's our student constructor method. So this will tell us how we build a student. We'll leave it blank for now. In other words, what's called a stub method. We wanted to make a public void method for how to study. Actually, why don't we fill that one in right now? Study should make our average go up, right? So what should we do? Let's say that the average equals, well, we could just add 1 to it, but it's a decimal number, so we might as well take advantage of that. Let's say average equals average, plus 0.1, right? That'll just add a little bit to our average as it rises, a little bit at a time. It's not like a whole number of change. Now, let's write a method to slack off. Now, we could write the same thing. We could say average equals average minus 0.1. But I think when you slack off, it does more damage than studying, myself. So I think it's going to be 0.1 times 2. I'm going to double the amount of damage by slacking off. So studying just raises it by 0.1, but slacking off causes more damage. This is my moral lesson to you guys right now as we write this code. I'm saying, sure, you can study, but slacking off has more of an effect on your overall average. But luckily, there is a solution, and that's our next method, which is to cram, public void cram, which I'm hoping some of you are doing right now in preparation of your IB exam. You're saying, here at the last minute, what can I cram into my head? I'm going to be honest with me right now. How many of you ever gone into a big exam with this? I'm going to draw an analogy because it happened to me. I felt like I had a vase full of water on my head, which represented all the things I'd studied the night before. Nobody bumped me or I'm going to forget something. And I would go into the exam and then the second I got to the exam, I just felt like dumping it all onto the sheet. And then when I walked out, I was like, whew, I can forget everything right now. Does that analogy feel true for any of you in the room right now? A little bit? Okay, a little bit? Okay. So let's do a cram. How are we going to cram? Well, let's run a for loop. And for 10 times, let's study. Let's study 10 times. That's how we'll cram. So here again, I'm using actual code to have fun with you guys by just writing lines of code as if they actually have a real world equivalent. And that's where I'm hoping your coding is now. Yeah, we're still using the details of for loops and stuff like that. So I just say from 0 to 10, study, which calls this method, which rises it up by 0.1 each time. Slacking off raises it, drops it by 0.1 times 2, etc. Okay? So we're having a little fun with that. Okay? Now, the one thing we have left to do is our constructor. And as you recall, constructors set the properties in motion. So let's do that. So when we make a student, what's their student number going to be? Well, we don't know. So let's just make it 0. What's their average going to be? We don't know. So let's make it a 0. But That's usually not how we make a student. We just set up a blank student and then just let it roll. I don't think so. So after this method, let's overload our student method with a public student method. And let's start giving it a few parameters. But let's give it more than just student number and average. Let's start off with a name, string name, comma. How about int age, comma. Boolean is male, comma. Okay, how about the student number, comma. And how about their average? So now we're making a different type of constructor. This constructor for a student says, okay, I'm going to give you all this stuff right at the start. I'm going to tell you what this is like as if what would probably happen and more realistically. When you enroll a student in a school, they say, well, what's your name? What's your age? Like that's going to be put in there at the moment they construct you within the school as a student. Okay, we're going to skip the first three. We know that to set the student number, we'd have to say something like this dot student number equals student number. You may recall this from back in the person class. I showed this to you back here. Do any of you remember why we put the keyword this there? Like, what does that mean? Does anyone remember? Put it back here to student for a second. It confuses it, right? Because same with this one. If I just say student number equals student number, it's confused because we have two versions of student number here. We have the one that's sitting here as a parameter, which I'm going to circle in green, which is the same as this one here. That's the same one. But this one right here is part of the class. That's student number. And by putting this in front of it, like that, it knows you're talking about that one. So now it makes more sense. So if I send this method the number 10 as a student number, it passes the 10 along into here, and then it passes the 10 into here, which is really passing the 10 into here. So it's really directly putting it into the property that way. That's what the keyword this is doing. It's being explicit about the name of the class. If you don't quite grasp it, that's okay. We're going to work with that a little bit more. All right, yes? Okay, we'll get to that. This dot average equals average. Okay, now, what about the other three? Name, age, and is male. And as Dawson pointed out, we can't change them. How do we get to this other class, the person class? Well, here you're going to learn about how those words that I was mentioning affect the code. So we'll just pause there for a second. We had to do these two lines. The student number equals the student number, and the average equals the average. That's true, but what about the other three? So let me catch you up with the slide notes. So we've already done this part. We created a new class. We used the keyword extends, and it picked up all the properties and methods. So that's how we started. We built our student class, just like you see there. We did that. Okay? We started rewriting the constructor, and now here comes the keyword. With the constructor, we can actually make a call back to person. And we use the keyword super to do this. So notice the keyword super appears in blue. If I then put a dot after super, you can see here I can start changing things. Because super in this context means the super class, which means person. So I can change the name, the birthday, and all that stuff. But here's the way I can also use it. I can also call methods like die and talk. I can call those methods. But when I do this, what do you think I'm implying with that line right there?
That nothing's private.
Well, what do you think super with brackets beside it? What do round brackets usually mean? A method. If it's a method of the superclass, super, it's a method of person, person. Well, which method is that? Well, that's the constructor method. So if I just put super with empty brackets, I'm essentially calling this method right here. Well, I don't want to call that method. I want to call this one. And that's called the super constructor. So I'm going to say super name, comma, age, comma, is male. And what it does is it passes these three things along to person class and fits them into here. So it's jumping from one class to the other. And that fixes our age problem. So now name, age, and is male are passed along. Okay, this is a bit tricky. So let's put this to the test. Let's go back here. Let's make another student. Student, give me a name, please. Okay, no, let's pull back to your movies. So your favorite movie that involves a high school student, what would that high school student's be? Marty. Okay, so we'll have student Marty equals a new student. And we're going to use our second constructor. So within this student, we're going to give them the name Marty McFly. The student's age, I guess it's about 17 in the film. Is a male? Yes. Oh, wait, we got two more parameters. His student number. Oh, I know what his student number should be. 88, that's right. And what should his grade point average be? No, it didn't seem like that smart. How about 1.80? Okay. 2 is low, yeah, you're right. Let's go 2.8, there. No. 2.80, that's going to be Marty McFly's thing. Now, that's a long line of code, but what is happening there is in the moment I write this line, a lot is happening. It is building a student object, okay? So I'm going to diagram this for you. That line of code just said, okay, here's what you got to do. You got to make a student. Okay, I'm about to do that. What's in a student? Oh, a student number. So you got to give it a student number. This is some integer. Well, what goes into that box? Oh, well, you just told me what goes in there. 88. What else needs to go in there? Oh, their average. And average is a little bit of a different box because it holds double, so it's a little bit more precise. And oh, you gave me the number that goes in there. It's 2.8? Yeah, so that's their average. But wait, that's not all, because a student is a person. So when I make a student class, I'm also building a person class. Like a student is a person. So that means you're going to have to also give me their name, which is a string. You're going to have to give me their age, which is an integer like this one. Make it a smaller box. You're going to have to give me the is male, which is a Boolean, so that's a really small box. And is alive, which is also a really small box. And all of this is part of the person class, and the person class is part of the student class. And you passed me more information. You gave me their name. You gave me his age. You gave me is male. And I'm setting this one automatically when I construct it. All of that was just put into memory with that one line of code. It did it through the constructor methods. All of that went together. And that was just one student I made. All right. Yes. We'll stop there today. So I need a verb and an adjective. Right now, quick, before I wrap up.
Die.
No, it doesn't fit. It has to be a positive verb. Jump. Jump on. Okay. And adjective?
Saucy.
Saucy. All right, everybody. So as I finish today, jump on that saucy subscribe button, and we'll call it a day.